Now let us look at the concept of a wheel rolling. Okay, so we have a wheel here. This is the center of the wheel. This is the point of contact of the wheel with the ground. We are assuming that there is only one point of contact. Generally there will be more, but as a concept we have to assume that there is only one point of contact. Now this is going to be the radius. Now as the wheel rolls forward, after some time it's going to come to a new position, right? And this mark will again be touching the point of contact, or rather you mark a point here, and when it goes one full rotation you will see the same point is touching the ground again, and that is the time when the center of the wheel has moved forward by a distance of 2 pi r. And since we are having it move on a flat surface, you will see that this distance is equal to the distance on the ground as well. So in other words, when a wheel moves one full rotation, its center moves forward by a distance of 2 pi r. So if a wheel moves n rotations forward, then the distance traveled, the linear distance traveled by the center of the wheel is going to be 2 pi r n. So here we have a few things that we are going to use to conduct a small demo to find how far a wheel moves as it rotates once. And also we'll use the same equipment to find the value of pi. So we have here a steel scale, reasonably straight. We have a vernier caliper. This is basically an instrument which can help us measure the diameter quite accurately, right? Then we have a flexible scale here. We have a flexible scale here, so this can rotate and measure around the cylinder if required. And we also have here a roller scale. This is again a flexible scale which is much more finely calibrated. Okay, and of course we have a can which is pretty uniform and therefore can act as a good wheel, and of course a pen and a pencil. Let us now find the circumference of the can. So we'll use this flexi scale which will roll around or wrap around the can. Keep the 0 on the white. The 0 here has a line above it which kind of coincides, and this will come down to about 18.3 centimeters. So here we have a simple arrangement just to verify that the circumference is the distance that the wheel travels in one rotation. So what we've done is, see, we have put a mark here, right? Of course a couple of marks here just to see the rotation as it happens. I put a flexi scale here and I have marked the circumference. So if I start from here, this point should go all the way and come back and hit at this point, which is about 18.3. So this goes, turns, and there we have it land at exactly the point that we predict. Okay, so you can see that when the can makes one full rotation, it has traveled the entire distance which is equal to the circumference. It is very important to note that it is the center of the can, the center of the can or the center of the wheel which has made this linear displacement. And just because we are on a flat surface, the distance on the ground is equal to the distance that the center of the wheel is traveling. If this surface was not flat, that would not have been true. You can verify that by looking at the coin rotation paradox once more. So here I have a roller scale. It's a very interesting scale and is generally used to study certain engineering courses, especially in engineering drawing. So you have a roller, you can see it is resting on these two red rims, right? Now the scale here has been marked, so it's marked for 6 centimeters. The circumference of this red thing is 6 centimeters. Now I have aligned it to the top notch at 1. Okay, and I have made certain marks at 1 centimeters each. So I'm just aligning it so that this is 1 and this is at the first mark. Now you'll see that as I move one full rotation such that this 1 comes back to the same position, it would have moved forward about 6 centimeters. Let's see. We're starting from 0, 1, 2, 3. You have to see here is the third mark, fourth mark, fifth mark, and the sixth mark. You can see the 1 is back to its original position. So the roller scale also works on the same principle, that as you go one full rotation, the scale would have slid by 1 circumference.